To demonstrate AutoRegistry in a toy project, we're going to parse data from a variety of files and print it to standard out. Here we have a skeleton of a program where we parse a single argument from the command line file, and then we get the extension of it without the dot. We're going to have three data files for this project. We have a data.csv, which has two columns, name and age for Alice, Bob, and Charlie, and their ages 25, 42, and 50. We'll also have a data JSON that has all the same data in JSON representation. And then finally, we also have a YAML file, which has all the same data. So if we were to construct this, let's start from our main file, and we would like to construct a base class for our data readers. For a lot of these simple readers, we technically don't really need a class, but imagine if we were to use a more expensive interaction, like let's say with a database or with a third-party API. So for those situations, you would need more setup where a class makes more sense. So let's call our class store, and let's inherit from the ABC base class. And we are going to define a single abstract method, and we'll call it read. That will take in a single argument path, which is the path to the file. And so we'll say raise not implemented error because our subclasses will implement that. So let's copy our store and let us write a subclass for JSON files. So let's call this JSON store, and let's implement the read method. So for this, it would look something like with open our path in read mode as f, and then we'll do return json.loadf, and then we'll also need to import the JSON library. Down in our main function, if our extension is JSON, then we should instantiate the JSON store class. Otherwise, we will raise a not implemented error because we haven't implemented readers for other extensions. So raise not implemented error. From the store, we can be store.read, and we can pass in our args.file, our passed in from the command line. And this will be our data, and then let's just print it. So we can say print data equals. So if this is all done right, we can go down to our terminal below and say python main.py, and then let's pass in our data.json. And here you can see that it loaded and parsed all the data correctly and printed it out. So let's do the same thing for CSV. So we're going to define another subclass called CSV store. That's also inheriting from that store base class. And let's actually copy a lot of the stuff from the JSON store because it's going to be kind of similar. Instead of importing JSON, we're going to import the CSV library. And then instead of using json.load, we will do csv.dictReader and pass in our file handle. And so I think that returns a generator, so let's just cast it to a list so that it loads it all into memory. So down below, just to confirm that we didn't break anything for data.json, that still works. So let's try and pass in our CSV file now. And we get a raise not implemented error, and that's because while I did implement the class definition, I never actually shoved the logic down here into this if else if statement. So right there, that's already a bit of a downfall, was that me as the programmer, I had to remember that I had to add additional code in other locations of the code base to get this to work. So for now, let's just say if the extension is CSV, then instead of a JSON store, we are going to use a CSV store. And then hopefully now, if we were to run it with the CSV data, it works as expected. Okay, so we just saw the downfall of that approach. Let's try and move some of this logic out of this main function. And we could do that by, instead of having an if-else statement, we can have a lookup table or a dictionary. So if we were to define something called store lookup, a dictionary that would map our extensions to our class constructors. So we can map JSON to JSON store, and we can also map CSV to CSV store. And then down in our main, we can get rid of this if statement, and we can just simply say store equals store lookup. We index in with our extension, and then we call the class constructor. So we can get rid of this, and if we run it, everything should still run perfectly fine. So this is a bit better because now I'm not directly editing logic in my main function, and instead I'm just updating this dictionary definition. So if I were to be reviewing code, I'd be less nervous to merge something in because the logic is not being modified. We're just directly adding an additional item to this store lookup dictionary. But so, as the programmer, I still have to remember to add in my, my constructor and string into the store lookup every time I implement a new class, which could be, you could easily forget to do it. So a different design pattern is to use a registry. So inside of our store base class, we can implement the dunder init subclass method. What this method does is every time you define a subclass, this method will execute with that subclass definition. So here, I'm just going to demonstrate this by saying name is class.underName to get that attribute. And then let's just print out what this is so that, we can feel a little more comfortable about it. So name equals, and then let's say what class equals. So just by implementing this method, whenever we run this code, we can see name is JSON store and class is the JSON store class. Same thing for CSV store, the class is the CSV store class. So we know, given our current naming scheme, that our classes are always going to end in store, and the first part of the class name is actually the extension for the data that they support. So we can implement a little bit of logic here in the init subclass to take care of a lot of this for us. So let's first just assert that name ends with store. And this will enforce a naming convention in our code base so that we just have consistency everywhere. And then better still, we can say our extension is going to be our name. But if we were to chop off the store part of it, and then if we were to make it all lowercase, because our extensions will always be lowercase. So that'll be our extension. And then now we can automatically put this in a dictionary. We'll create this dictionary as a private registry class variable. And then we can store it here as class.registry for our extension, and we'll store our class constructor. And I'm gonna go ahead and get rid of this print statement. Now I made the registry class variable private, and so we should implement a class method so we can access it. So if we use the class method decorator, and let's define a function called getConstructor, and for a given extension, we should return whatever constructor we get from our registry for that extension. So now down below, instead of using our store lookup, we can instead use store equals store.getConstructor for our extension, and then invoke that constructor. So I'm going to delete the store lookup part, and let's see if this still runs. And it still runs. So we can now safely delete this store lookup. So the benefits of this method is that every time I implement a new class, it will automatically be registered. So I only have to make edits to a single location in the code base. This is great from a PR perspective because whenever I make a pull request, I don't have to be mentally thinking about a bunch of different locations in the code base. And then also, because I'm not worried about a bunch of different locations, I really only need to unit test the new code that I added. So yeah, this is done with the registry design pattern. But this can be cumbersome. There are some cases here that we didn't actually handle. There's a lot of things that can go wrong here, and especially if you are defining a bunch of these, base classes that have registries, you'll be copying this logic around a lot, and that's bad from a dry perspective. So what we're going to do is we're going to use the AutoRegistry class. So this is pip install AutoRegistry, and once it's installed, you can say from AutoRegistry import registry. So what we're going to do is replace the ABC base class with registry. Now, registry inherits from the same ABC meta class, so stuff like abstract method will still work. Now that this is inheriting from the registry base class, we can actually delete all of this logic that we just implemented because that's all taken care of for you. So now we're just left back with that abstract method that our subclasses need to invoke. One last thing, we are going to pass in some configuration parameters to the registry base class. Namely, we're going to pass in this suffix keyword, and we're going to say that all subclasses must end in capital S TORE, store. And so this will do two things. One, it'll make sure that all subclasses are ending in store, so that maybe some other developer or maybe me in the future forgets the naming convention, and I might say JSON storage, and it doesn't really match everything else, which could cause issues. So that enforces that naming convention. And then also, whenever it's registering it to its registry, it will strip the suffix and just store it as JSON, which in our case is our extension, which is nice. Down below, we were previously using that class method we made, getConstructor. With AutoRegistry, we can just directly index the class as if it's a dictionary. So we can now just use square brackets and say store for a given extension that will return our constructor for the subclass, and we can invoke it. So now with all of this, if we were to rerun the code, it works just as expected. And because of this, we can now very easily implement a new class. We'll call it a YAML store. And we'll just copy our code as we did before, but instead of CSV or JSON, we'll implement it for YAML. So we're going to be opening the file, and then I believe it's going to be, we can get rid of all of this. It'll be YAML.safe load of the file. And so I only edited these 5 lines of code. I didn't edit code anywhere else. But now if I were to pass in a YAML file, so here will be our data.yaml. I have a syntax error. And now it works. So that seems like a bit of magic, but basically what AutoRegistry does is it transforms your class into a dictionary for all subclasses. With some configuration parameters, it can work recursively. We can enforce suffixes, prefixes, different naming conventions, like if we want to convert the keys from just lowercase to snake case, or anything like that. Just to get a little bit more familiar with this registry that we just implemented, let's drop into Python, and then from this main function or main file that we just wrote, let's import our store class. And now if we were just to get the representation of store, it shows us that there are 3 elements to it: JSON, CSV, and YAML. And so if I were to index into this with JSON, I get that JSON store constructor, so I can create a JSON store object that way. By default, AutoRegistry is case insensitive, so I could have also called this JSON, and it will correctly get the correct constructor. I can do other things like you would with a dictionary, like if I were to cast the store class as a list, I would get a list of the keys. If I were to do store.items, I would get the list of tuple of key value pairs. And then if I were just to do store.values, I would also get all of the constructors, just like you would from a dictionary. You could also do things like store.get. Let's say if there was a bin binary file that we haven't implemented yet, this would return none. But if we wanted to fall back to, let's say, always assuming it's JSON, we can provide that as the default argument. And so now we get that JSON store class again. So AutoRegistry is a way of enforcing all these class names, making your code very concise, making it so that whenever you want to extend an interface that you've defined, you only have to edit code in one location, and everything else will just work automatically. So thank you. Check out AutoRegistry, pip install AutoRegistry, and see you next time.